So definite integral we already started in the last session, and we have discussed one exercise based on indefinite integrals. Now here we see some properties which are very fundamental properties of definite integrals. So let's state those properties first. So the first property is, you know it, integral a to b fx dx is same as if I change the limits minus b to a fx dx. That we know, where I already stated earlier. This is one property. The second property is, if you have any number c between a and b, c is any number between a and b, then integral a to b fx dx, you can split into two integrals like this: a to c of the function fx plus here plus integral c to b fx dx. Integral a to b, you can split from a to c and this a to b. Or the another way of saying, if you have such two integrals where these limits are common, then you can just convert into a single integral, remember. For example, like this, if I have integral 0 to 2, for example, of some function fx, then if you want, you can write 0 to 1 fx plus 1 to 2 fx, remember. Any number between these two can be selected here. That depends upon the question. We'll see in such examples. Okay. Now, next property number 3, third property, that's very important. That says that if you have integral a to b fx dx, then you can write a to b here, f of this x is replaced by lower limit plus upper limit minus x, so a plus b minus x dx. Very important property. 90% questions are based on this. If you cannot solve by indefinite integral, mainly this property help us. Integral a to b, this integral is replaced by, limits are same, but here x is replaced by lower limit plus upper limit minus x, remember, in the function. Instead of x, it is a plus b minus x. That's lower limit plus upper limit minus x. And as a particular case, we have the next property here. If you have 0 to a fx dx, is the same property. Then 0 to a, x is replaced by 0 plus a minus x. So that is f of a minus x dx. It's just above 1 only. X is replaced by 0 plus a minus x, that is just a minus x. X is replaced by a minus x, remember. What is the above one? X is replaced by a plus b minus x. One is this here and the one more is this. Here 0 to a, here a to b. Properties are same. Very, very important properties, third and fourth, you will see. In 90% of the questions will use this if you cannot solve by indefinite integral. Okay, we'll see. I'll just remind you when we do exercises. Okay. The next property number 5, that is here, integral 0 to 2a fx dx, that you can split here 0 to a plus here it is again 0 to a, but now x is replaced by 2a minus x. Now question is, why this? That might be question in your mind. Even that such questions you may have in this property also. Okay, why this? Now this can be proved very easily. You can start with this, take this as a t, and from this you can derive this. Proof is not so important. You can refer the textbook also. It can be derived very easily. These are theoretical things. You take these as a t, and from these you can get this very easily, remember. So proofs are not important. I'm not getting into that. If you are interested, refer the textbook. Still, if you find any query, you can of course ask me. So why this, that question might be there in your mind, that why this is replaced by this. So it can be derived, remember, from this RHS to LHS can be derived very easily. At this point of time, proof is not so important, but these properties are important. 0 to 2a is replaced by 0 to a, 0 to a. Here fx only, remember, but here it is 2a minus x, remember. X is replaced by 2a minus x. Now the next property is 6.1, 0 to 2a fx dx, that is equals to here twice 0 to a f of x dx, where if this is true, these two functions are equal, that is f of x is same as f of 2a minus x, remember. If this is true, f of x is same as f of 2a minus x. If these two things are equal, then you can see that these both are equal, so this will be double. This also will use at least in 1 or 2 examples, you will see. I'll tell you at that time. But here, this is very important condition, that is here x is same as f of 2a minus x. This looks like period, you will see later on, I'll tell you. And the last important property here, property number 7, that is if you have opposite limits minus a to fx dx, opposite limits like minus 1 to 1, minus 2 to 2, if you have opposite limits, then the value of the integral is 0 if f is an odd function. We have studied even and odd functions in 11th standard, if you remember. F is an odd function, like this. F of minus x should be same as minus fx. For example, you know sine, then x cube, these are the odd functions. We know it, we did it in 11th, if you remember. If function is odd here, odd means minus x will come out from the function. This property, just recall 11th standard. If odd function, if you are given inside the integral, and if you opposite limits, then the value would be 0, like this. For example, if I want to evaluate this integral minus 2 to 2, and I'll put x cube. So here, this being odd function and opposite limits, the value is 0. You can find actual integrals, you can verify. What's the reason here? Because fx equals to x cube is an odd function. Is an odd function. What do you mean by odd function? As I told you here, that when you replace x by minus x, that minus sign will come out and it is just fx. You know it, we did it in 11th. Okay. Suppose I want to get this integral, minus pi by 2 to plus pi by 2. Limits should be opposite, remember. And I have, for example, sine cube x. This is also 0. Why? Because sine itself is an odd function and cube is again odd function. So integral is 0. What's the reason? Same. Is an odd function. Okay. Now here the second part, in case if this function is even, then this will be twice 0 to half limit 0 to fx dx. If f is an even function. F is an even function. What do you mean by even function? X is replaced by minus x, then the function remains same. If you put x by minus x, then the function remains same. This is called even function. For example, cos is even function, x squared is even function, and so on. If you have opposite limits, then you can just reduce this. Directly you cannot find the value, remember. But limits easy हो जाएगी. यहाँ पे minus a to a था, यहाँ पे 0 to a हो गया. Limits would be easier, remember. This is property number 7. If you have even function, then twice 0 to f x dx, where f is an even function means this. And if it is an odd function, then the value of the integral is 0 directly. This is the property number 7. I hope this is clear to you. Like this, if I write third example here, suppose I want to evaluate this minus 222 x squared. Now you cannot write directly answer here, but at least this much you can do. This is even function, you know. So twice 0 to 2 x squared dx. And now you can continue further for the integration x cubed by 3 and upper minus lower. What's the advantage of using this property? Calculation becomes little bit easier because now one limits become 0. Here both the limits were non-zero. That's the only advantage, remember. You need to do the integration, remember. Here for odd function you could find directly answer which is 0. Here direct answer you will not get, but calculation as far as the limit concern become easier. So whenever you see such opposite limits, minus a to a, always just check whether the given function is odd or even. If it is odd, answer is 0. If it is odd, you can do like this. But limits should be opposite, remember. That you have to keep in your mind. Especially this would be helpful in MCQs or in 1 mark or questions. Whenever you see opposite limits in any question, just think about whether the given function is odd or even. If it is none of these two, you cannot use this property, remember. Okay, this is the property number 7. Property number 6. If the function satisfies this condition, then 0 to 2a becomes twice 0 to a. You see here limit becomes half. This was 2a, here it becomes a. Previous property, you can split 0 to 2a like this. And earlier properties, the property number 3 and 4, these are the very two important properties. If you have a to b integral of x dx, then x is replaced by a plus b minus x. Your x is replaced by 0 to a. If c is any number between these two, then you can split into two integrals as I've shown here. And if you change the limits, integral would be opposite. Okay. Each of these properties, as I told you, can be proved very easily. I'm not getting into the proof. We directly go to